Perfect. So I will start my presentation. So fifth place solution for the Bengali.AI speech recognition challenge. My name is Benedikt.d. Yeah, we have some items on the agenda for today. So first, I would like to introduce myself. After, I would like to present a short summary of my solution. And after, we will jump into the details of each step of my solution. And in the end, we have some time to do the questions and answer part. And yeah, I received some questions from you, Ashley. I integrated it in the presentation, and we can refer to these questions. Yeah, my name is Benedikt.d. As I already said, I'm head of business analytics at MSR Consulting. We are a management consultancy in Germany. And in my day-to-day job, we focus on traditional statistical analysis. So not the deep learning stuff and so on. This I do mainly at Kaggle. So currently I'm Kaggle competition master with 3 gold medals. And I focus mainly on the deep learning topics, NLP, computer vision, and so on. And I try to stay up to date with most popular frameworks, with state-of-the-art techniques, and so on. And that's why I really enjoyed this competition. It was a really interesting topic. And yeah, that's to me. And now I would like to share my solution. The overall solution is pretty straightforward, I think. So for the RSR model part, I choose a wave-to-wake backbone. Why is that? Early in the competition, I tried a lot of different backbones, and I also tried Whisper, because the Whisper paper shows that Whisper is superior to wave-to-wake in regarding the performance, and it shows that even if you have just a small amount of data, the model should really learn the language quite well and should perform very well. But surprisingly, Whisper, in my experiments, performed always worse than wave-to-wake in the beginning of the competition. I choose a 2-stage training process. Why that? I will refer to the details later, but it showed that not every sample in the competition data is useful to train the model. So I filtered the data in 2 steps. The first step was the Mo scores, which were provided by the competition host after some weeks when the competition started. This was the first metric I used to filter the data. And after I pseudo-labeled the whole data set, calculated the word error scores, and filtered in a second stage, so reduced the amount of training data again, and retrained the model. What is quite unique about my solution is the ensembling part. I think, and correct me if I'm wrong, no one in the top 20 did successful ensembling. It was written in the forums as well. People search for a solution, and I will provide a possible method to ensemble the output of RSR models. Yeah, the language model part, really straightforward. I think everyone who used wave-to-wake also used CanLM models. So I did. I cleaned and filtered the large text data sets, more details later, but it was really, to be honest, the boring part of the competition to work on the language model. Punctuation, I choose XLM Roberta Large. And if you think about it, we have the RSR model, we have the language model, and it produces raw text. So you have no kind of punctuation. And that's why you need a third model in this XLM Roberta Large to restore the punctuation. And in my case, I just focused on comma, full stop, and question marks. And last but not least, I normalized the final outputs with the BN Unicode normalizer, which was provided by the host as well. So if it is okay, I would like to jump in every of these topics now and providing more details. The first topic is a training procedure. As I already said, I started with Whisper and wave-to-wake backbones, and Whisper didn't succeed 0.5. So I always was behind with a performance of behind wave to wake, and that's why I completely focused on wave to wake in the next weeks. And as other participants saw as well, Indic wave to wake was very strong in the beginning. And I achieved a baseline score of 0.49 really fast, without punctuation, without a language model. And it was the best performing backbone at this time. And after some weeks, the competition host provided additional analyzers for the training data. And this analyzers also contained a MOS score for each sample. And this MOS score is something like a proxy for the quality of an audio file. And I just removed every training sample with a MOS score below 2.0. And after I retrained the model from scratch on the remaining training data, I think we talk about 700,000 samples of 1 million, which were left. And the score improved to 0.472. What is very important, before I did this quality filtering, the model reached very fast optimum. So if you train it, for example, for 30,000 steps with a batch size of 8, with all the training data, the local score will improve. Even after 3 POS, it will improve. But the leaderboard score, after some thousand steps, will decrease. And I thought about this data collection step. I think it is really really hard to get a high quality data pool from this data collection process, because you have people maybe with bad technical equipment. Maybe they start recording, they start reading the sentence, but press the recording button later, and so on. And usually I don't remove any training data, even if I know the sample is hard to predict, or maybe the annotation is not perfect, because I think it works like some kind of regularization to the model, like dropouts, which we do on purpose. But in this competition, the amount of corrupted training data was too high for the model. And I think Indic Wave to Wake performed so good in the beginning, when all participants used all the training data, because it was some kind of robust to this topic, because it was pre-trained on a huge corpus of Indian language, and this corpus even contained Bengali language, and a lot of other backbones I tried didn't have this prior knowledge. And I think this was why the full training data set in the beginning always tended to perform worse on other backbones. And also for Whisper, I think you heard the top winning solution. The key was as well to filter the data and to provide the right samples to the model. Now I talked a lot of the slide, but yeah, I pseudo-labeled the data in a second step, and I removed all samples with a word of error score above 0.5 for my model, and 0.5 for the Yellow King baseline, because I wanted to ensure that it is no model-specific related problem for my model, but the sample is corrupted in any way. And as I thought, if my model can't predict half of the words correctly, and this is what the score basically says, and Yellow King also can do it, after the model saw 1 million samples, there it can be. So the training data must be corrupted in any way. And that's why I choose this threshold. I didn't do much test. I just said 0.5 should work. I think 400,000, 350,000 samples were left after the steps. And I retrained the model, and the public leaderboard score increased to 0.452. And at this time, I thought, I should redo some experiments from the beginning. So I tried a larger backbone, for example, Wave to Wake 2 XLS R1B. The main difference is to the Indic Wave to Wake, it is more than 3 times larger. So 1 billion parameters compared to 300 million 1 billion parameters compared to 300 million parameters. and it was open source. It had the correct license, and I retrained the model just for 130,000 steps, and the model scored 0.454. And unfortunately, I had no time left, so I was a one-man team, and I did many steps parallel, and I had to skip any further training because I wanted to try the ensample. So I think it is really undertrained, and I think with a quality filtered data, you could even try larger backbones. So from my point of view, you could even try a 2 billion parameter backbone. Whisper, the top winning solution, showed that Whisper is trainable with filtered data. So there are a lot of possibilities. The problem was I really focused on Indic Wave to Wake because of the beginning of the competition. If you look in the top right corner, I added on each slice my point of view to the further potential of the part of my solution. And I think here's really some potential left, because you can try a lot of different backbones. You can try other hyperparameters. I didn't tune this model a lot. I just lowered the learning rate, and it was like a one-shot setting, and it worked really well. So now is the question, why I talk the whole time about two different backbones when most of the teams just used one backbone, because ensembling didn't show any good results. I made it working. It doesn't work if you just take the logits of the outputs and try to average them or try to weight average them. Why is that? The outputs for a specific time step is not guaranteed to align. And that's why sometimes it's a prediction for one letter maybe a little bit better, sometimes it is worse, and so on. And if you ensample two models with the same performance, the score will not change that much. Maybe slight worse or slight better, but most of the time it will just be the same score. And at this point, I started to read a lot of paper. I think I read nearly every paper regarding this topic, because it drove me crazy that there's no solution for ensembling this model outputs. And I found a 5-page paper, investigation of ensemble features of self-supervised pre-trained models for automatic speech recognition. And the authors tried to improve the performance of pre-trained backbones by ensembling them, and they even took different architectures. So they took Hubert, Wave to Wake, Wave LM, and they took the features, so the last hidden states, concatenated it to a large matrix, fed it into a transformer encoder, and on top of this transformer encoder was just a linear layer with the output size of the vocabulary. And the results were really promising, but they unfortunately didn't link any GitHub repository or any code. But yeah, it is easy to adopt. So what I did, I took my fine-tuned Indic Wave to Wake backbone, my fine-tuned XLS backbone. I freeze the parameters in the second training process. I extracted the last hidden state in every step, concatenated the features. I just took a very small transformer encoder, 2 layers, 6 heads, and fed it into a linear layer with the output size of, I think, 65, because this is the size of my vocabulary. And it was the second last day of the competition, and I had no time left to do any experiments. So this was the only training run I did. I had to migrate my old setting into the cloud, because 24 GB VRAM are not enough. You need 48 GB RAM to train this model with a batch size of 8. So I had to migrate all my stuff into the cloud on the second last day. I gave it one shot. I trained it for 6,000 steps. And as you can see, the word error weight, we started with a value around 10, and it decreased nearly by 1. And this was the only ensemble model I submitted in this competition. The only successful submission, and the public leaderboard decreased from 0,355 to 0,344. And after the competition ended, I checked the private leaderboard score, and it worked even better on the private leaderboard. So from 0,443 to 0,429. And from my point of view, in this part of my solution is the biggest potential. Why is that? We have a small backbone with indic wave to wake. We have the undertrained larger backbone, and you could try to ensemble more models. You could try to ensemble even different architectures. And I didn't tune anything. So this was a one-shot setting. I just took a hyperparameter setting from the previous training phase. I didn't tune any higher parameter. I didn't tune this part of the model, so I didn't try different amount of layers. In this paper, which is shown here, the author shows if you take more layers, for example, 8 transformer encoder layer, and so on, you make this part larger, the score will improve. And I had, unfortunately, no time left, but from my point of view, in this part is the biggest potential of my solution, because it can be combined with other solutions as well. So you can just take the other pre-trained backbones and give it a try. So from my point of view, a very interesting part and unique in this challenge. The language model, really straightforward, to be honest. I took the competition data. I took IndiCorp, like I think every other top team as well. I took the transcriptions of OpenSLR 5.3, and I used the CanLM library. And one of the competition hosts wrote in some forum post that there will not be any new characters in the hidden test set. And that's why I limited the characters of this training data to the vocabulary of the RSR training data, so to the transcriptions, because I wanted to ensure to focus on the right characters, the right words. I didn't want to introduce any new characters and so on. I replaced numbers, other languages, characters, etc. with special tokens. To be honest, it didn't improve the score much. I went to this pipeline, I spent a lot of time to this language model part, but you can nearly take the data as it is, and it works surprisingly good. I pruned the model, which means, for example, if you have a 4 gram in the data, it must appear 3 times to be recognized. And I just did this because I had a lot of restrictions in the Kaggle environment, because you have to just this 13 GB of RAM. More interesting from my point of view, for practical use, the CanLM library has some bug, and the Hugging Face implementation as well. So if you load the CanLM decoder and delete it, the RAM will not be freed. It stays in the RAM even if the object is deleted, and you have to manually call this decoder cleanup function. I searched the whole GitHub repository of CanLM, and I found this unsolved issue. And if you do that, the RAM is freed, and it was very important for my solution, because without the step, I always ran into out-of-memory errors. And it was quite challenging to get all these models and all this stuff into the Kaggle environment. So I calculated the logits with ensemble model. One by one, I saved each logit as NumPy array locally. I deleted the ensemble model. After I loaded the decoder, I decoded every sample one by one. I cleaned up the encoder, deleted it. After I loaded the punctuation model, did the inference part for the punctuation. I deleted the punctuation model, normalized the data, and did the submission. Without this very fractured pipeline, I won't be able to run my solution in one workflow. maybe interesting point, it took the 9 hours. So I was really limited. It was like 8 hours and 55 minutes. So I really tried to press everything into the Kaggle environment, runtime, and so on. Further potential from my point of view, very low. As I already said, I spent so much time on this topic. Really, I did so much steps. I did so much experiments, but compared to the very first baseline solution, you can just take the data set as it is. Maybe there's a difference if you take some social some reviews from social media or some social media stuff, because you have all the smileys and you have not correct language and so on. Maybe there will improve the cleaning steps, the score. But for this data, it was very good in the beginning, and all the steps I did, it didn't improve that much. And I tried a lot of different data sources. I had sometimes binary files with a size of 200 GB, and the performance didn't improve any further. So I think not that much potential left. Early in the competition, some of the competition hosts wrote that you also score the punctuation part. And I searched for some papers, and I found a very good paper which addressed this topic, punctuation restoration for ASR model outputs. And they had a GitHub repository, and it was really a nugget, because they had a special model for Bengali language, and it was open source, and it worked surprisingly well. So this model was trained for 4 classes. So other, no punctuation is added, comma, full stop, and question mark. And if you take this sentence, for example, when words fail, music speaks. So every token is fed one by one through the model. And after each token, there's a prediction if the class is other. This means there's no punctuation mark added. So for example, start of the sentence token, when token, words token, always other is predicted. After fail, a comma is predicted. So the model will add a comma to the sentence. And I didn't do any fine tuning on it. Because it improved the score by 0.02. It was really a huge boost. And I thought, or I feared overfitting on the training data. I thought, if I now take the training data and I will add some more punctuation marks, maybe I will overfit, and this works so good and it works out of the box. And so I stayed with the model. I think it was a mistake, because the other top solutions showed here's still some potential within this part, because you can add, for example, a semicolon and so on, and it works. But I stayed with this pre-trained model. I just adjusted the inference function a little bit. So I forced the model to predict a question mark or a full stop in the end, instead of have all the 4 possibilities. This gave a small boost of 0.002. And basically, very important part for the solution. You can't have a high scoring solution without punctuation. Further potential, as I said, I think retraining makes sense, but it will not improve the score that much, but maybe a little bit. So it is worth a try. I created a small overview, because Ashley, you hand over some questions today. I thought it might be interesting for you which part was important. So the ASR model part, I can't say how much it boosted, because it was basically the base for the solution. As I said, I think here's still some solution, try different backbones and so on. The ensembling part gave a boost of 0.011 for the public leaderboard. Huge potential from my point of view, because nothing fine-tuned in this step. It worked really with the first shot. The language model, I think if you remove it, it is an estimation. I didn't test it because I had my pipeline in the Kaggle environment. I didn't do split submissions in the end. But I think it improves the score by 0.06. It's an estimation. But as I said, I think he has not much more potential left. And the punctuation part, I tried it early in the competition. Maybe it is a little bit less or a little bit more, but 0.022, yeah, with a medium amount of potential from my point of view. So I think it took too much time already, but I hope you have some time left because we have the question and answer